prepare. Liquid solution. Chemistry. Ah. Hmm. Hmm. Yeah. Correct. Ah. Correct. Yeah. Good afternoon, students. All of you. After after 3 days, we are meeting. Long 2 days over, no? So everyone revised the last topic, concentration terms. In the last class, we completed mass percentage, volume percentage, mass by volume percentage, mole fraction, molality, molarity, normality, dilution law, mixing. Till that we completed, correct? So write today's date. Now today we will discuss new concept, that is solubility. Right, solubility. Now in our syllabus, what is solubility? The amount of solute present in 100 grams of solvent to form a saturated solution. So I repeat, what is solubility? The amount of solute present in 100 grams of solvent to form saturated solution at a given temperature is known as solubility. So write definition: amount of solute present in 100 grams of solvent to form saturated solution. What is meant by saturated? Adequate amount of solute we are adding and we are dissolving to form saturated solution. Are you all practicing, students? Till now what we completed daily, I told you to recollect. So problems on till now what we did, you have to practice on that. So this is what amount of solute present in 100 grams of solvent to form saturated solution is known as solubility. So clear, all of you, copy that. So amount of solute present in 100 grams of solvent. So therefore solubility is given by mass of solute by mass of solvent. This is what solubility. So how much amount of solute is present in 100 grams of solvent to form a saturated solution is called solubility. Clear? Copied, all of you? Now in our syllabus we have to study solubility of solid in liquid and solubility of gas in liquid. There are two concepts in NCERT. In JEE Mains they ask conceptual questions as well as numerical on this. So one we are having solubility of solid in liquid. So first we discuss solubility of solid in liquid, then we go for solubility of gas in liquid. Copy this. Understood? Amu? Now write heading next, copied everyone. Right. Next we go for solubility of solid in liquid. Now write heading solubility of solid in liquid. Now what is this? You are dissolving a solid in where? Liquid. Now see, the solubility of solid in liquid depends on various factors. So what are the factors? See, I mentioned here. One, it depends on nature of solute and solvent. On what factor it depends? They ask a conceptual question. Solubility of solid in liquid depends on nature of solute and nature of what? A solvent. It depends on what solute you are taking, what solvent we are dissolving. Second factor, it depends on surface area. Surface area of solute, that is solid. The third factor, it depends on temperature. What is the third factor? You people studied in 11th class, Le-Chatelier principle. See here, temperature will have influence on solubility of solid in liquid. The fourth factor actually doesn't have any influence, but even then we are writing effect of pressure. How pressure will have influence on solubility. So copy this. These are the four factors which influence solubility. What are those? Nature of solute and solvent, surface area of solute, temperature and pressure. Copy this. So in exam conceptually they ask you solubility of solid in liquid, on what factor it depends. These are the four factors. Copy it fast. Following students, everyone, are you revising till now what we completed from solutions? Types of solutions we completed, concentration terms we completed. So don't keep pending. Complete as the day on the day what we teach, immediately you have to cover that. Later when you come here there, we have to clarify with doubts. So soon we will get a FT, fortnight test we have, weekly test we have. So copy this. These are the four factors which influence solubility of solid in liquid. Clear? Now we start with one by one. First we discuss nature of solute and nature of solvent. Now observe here. Now first factor I am going to explain how solute and solvent will have influence on solubility of solid in liquid. Now see student, might be heard in first year chemical bonding, a phrase is there, like dissolves in like. Do you heard this phrase? What is that phrase say? Like dissolves in like. So what is this you learnt in first year chemical bonding? Ionic compounds are soluble in polar solvent. Covalent compounds are soluble in non-polar solvent. Are you getting my idea? What is that point say? Ionic compounds, like dissolves in like. Ionic compounds are soluble in where you people learnt in first year, no? They are soluble in polar solvent. You know what are polar solvent? Like water, ethyl alcohol, polar solvent, they are soluble. Whereas covalent compounds are soluble in where? Covalent compounds are soluble in non-polar solvent. What are non-polar solvents? Organic solvents like benzene, carbon tetrachloride. These are non-polar solvents. So it depends what type of solute you are dissolving in the solvent. For example, see student, I am taking NaCl. You people know what is NaCl nature? Sodium chloride is ionic compound, no? So it is soluble in which solvent? Polar solvent, no? That means NaCl, as it is ionic compound. So this ionic compound will be soluble in where? Like dissolves in like, no, it is soluble in water. You know, water is a polar solvent. Like water, ethyl alcohol, etc. So is it depending on nature of solute and nature of solvent or not? Same way I take another compound, carbon disulfide. You know what is the nature of carbon disulfide? Carbon disulfide nature will be what? Covalent. Carbon disulfide. Formula of carbon disulfide CS2. This is what type of compound? Covalent compound, no? So covalent compounds are soluble in where? These are soluble in non-polar solvent like what? Benzene. You know, benzene, soluble in benzene. What is the formula of benzene? In organic chemistry people study. Formula of benzene is C6H6 as well as carbon tetrachloride. These are all what? Organic solvents. So is it depending on nature of solute and nature of solvent or not? So simple. So in exam they ask you on what factor it depends. It depends on what type of solute you are taking and in what solvent you are dissolving. So simple. Ionic compounds will be soluble in polar solvent. This is what solvent? Polar. Whereas these solvents are what? A non-polar solvent. Clear for all? No doubt, no? So this is what first factor, copy it fast. All organic components are to be taken as non-polar solvents. And what are polar solvents like water, ammonia, acetic acid? Clear all of you following? So this is the first factor, nature of solute and nature of solvent. Now can I go for next? Right, next. Second factor, surface area. Copied all of you. This now see next factor I am going, surface area. Now see student, next factor is surface area of solute. Now what is the surface area? That means suppose see you take powder form. Do powder form of sugar you take and coarse form you take. Coarse means what? The one that is not powdered. So who will have more surface area when you compare powdered and coarse form? Surface area will be more for powdered, no? So more is the surface area, more will be the solubility. So can we say surface area of solute it depends or not? So we can say, make a note, solubility of solid is directly proportional to whom student? Surface area, no? That means when you take powdered sugar and coarse sugar, who will have more solubility? Powdered solid will have more solubility. So make a note here, powdered solute will have more solubility compared to than whom? Coarse form. What is meant by coarse? The one that is not powdered. Clear student following? So simple, more is the surface area of the solute, more will be the solubility. Done. Right. Now we go for third factor, right? Third factor. What is the third factor observed, student? Temperature. This is important. Effect of temperature. Now, what is this effect of temperature? You have idea in 11th class, equilibrium chapter, thermodynamics. You may studied Le Chatelier principle. Do you recollect Le Chatelier? We studied in 11th class, equilibrium. So, how this affect temperature will have influence on solubility of solid in liquid. Now, see student, here dissolution of solid in liquid, it may increase with increase in temperature, and some solute it may decrease with increase in temperature. That means solubility of solid in liquid, it can increase with increase in temperature, or some substances may decrease with increase in temperature, because it depends on what? Enthalpy of solution. You know, that is dissolution of solution, that we represent with delta H. What is delta H? Enthalpy. Are you getting my point? So, effect of temperature, some solutes dissolution may be exothermic, some solute dissolution may be what? Endothermic. And you know, no, exothermic reaction favor low temperature, endothermic reaction favor high temperature. Recollect in 11th class we studied Le Chatelier principle. So, here what we say, dissolution of solid in liquid can be either exothermic or it may be even endothermic. How it is exo and endo we will discuss in the coming session. So, hence temperature has influence. If it is endothermic, if you raise the temperature, solubility what happens? Increases. If it is exothermic, with increase in temperature, solubility what happens? Decreases. So, here make a note, effect of temperature. Here you write dissolution of solute. Dissolution of solute in a solvent. It can be either what? Exothermic. It can be either exothermic. It can be either exothermic. What is exothermic, student? Heat is evolved. So you remember in thermodynamics we show with the symbol delta H is negative. Or it may be what? Endothermic. What is endothermic? Heat is absorbed. And this we show with delta H is what? A positive. So it depends. That means dissolution, since dissolution of solute in solvent, it can be exo or endo. It depends. That means for endothermic reaction, what happens? Solubility increases with increase in temperature. Whereas for exothermic reaction, with increase in temperature, solubility decreases. That means dissolution depends on what? Here write dissolution of solute depends on enthalpy of dissolution, that is delta H. Are you following, students? So some solutes may be ectothermic and some solutes may be exothermic. So dissolution of solute in a solvent can be either exo or it may be what? Endothermic. Hence, what will be the influence of temperature means? It depends. Hence, what we say, solubility of solid in a liquid may either increase with temperature or it may decrease with increase in temperature. It depends on what? Enthalpy of dissolution. Are you following, all of you? So here write, make a note, next point. Copy them, all of you, this. Now see, let us take ammonium chloride. What is the formula of ammonium chloride? NH4Cl. It is physically solid. And we are placing in water. Then it forms what? NH4Cl aqua. And this dissolution is to be endothermic. Delta H is positive means what does it mean? Endothermic. So for this solute, tell me what will have what will be the temperature influence on it? Since it is endothermic, you know, no, in Le-Chatelet principle, endothermic reaction favor high temperature. So with increase in temperature, solubility of this solute, who is that solute? Ammonium chloride increases with increase in temperature since the process is endothermic. So here make a note. Since the dissolution, since delta H, what is delta H? Enthalpy of dissolution is what process? Is it endothermic or exo? Since the dissolution of this substance is exo or endo, students? Enthalpy of dissolution is positive. Positive means what it is? Endothermic. So what happens to solubility of this solid with increase in temperature? Hence solubility of ammonium chloride increases with increase in, hence solubility of ammonium chloride, what happens? Increases with increase in temperature. Clear all of you? So since the process is endothermic, see, sometimes they give, say, how they give delta H, here they give plus heat. If they give plus heat, it is what we write, delta H negative we write. If it is negative, we write in terms of delta H positive. Means enthalpy of solution is what? Endothermic. You remember in a thermodynamics chapter we learned this. Understood all of you? See, this is endothermic. So what happens to solubility of ammonium chloride? Increases with increase in temperature. Clear? Now take next example, calcium oxide. What is the formula of calcium oxide? Do you all copied this? Right. Say next example I am taking calcium oxide. You know calcium oxide is CaO. When you dissolve in water, what is water solvent? It forms calcium hydroxide and this dissolution is exothermic. Means what is exothermic? Heat is evolved. So since heat is evolved, according to Le-Chatelet principle, low temperature favors exothermic, no? So if I increase the temperature, what happens? The equilibrium will be pushed backward. You remember exothermic converts into endothermic. So with increase in temperature, solubility of calcium oxide, what happens? Decreases since the process is exothermic. So here make a note, since dissolution, since enthalpy of dissolution is what process? Is exothermic. Hence, with increase in temperature, solubility of salt, what happens? Solubility of solid, what happens, students? Decreases, no? Solubility of solid decreases. Why? Since the process is exothermic. Clear? Therefore, what we can conclude, solubility of solid in liquid may either increase with temperature or it may decrease with increase in temperature. We don't know, that depends on what? Enthalpy of solution. Clear? Understood, all of you? So in an exam point of view, if they ask what happens to solubility of solid in liquid for exothermic, if you increase temperature, if they ask, for exothermic with increase in temperature solubility decreases. If it is endothermic, solubility of solid increases with increase in temperature. But in general we can say it may either increase or it may decrease because it depends on what? Enthalpy of solution. Clear? Up to this understood all of you? So first we discussed nature of solute, nature of solvent, surface area and how will be the influence of temperature. Now let us see on what factor enthalpy of dissolution depends. Means the reaction is exo and endo, we learned, no? So on what factor this enthalpy of dissolution depends? There are two factors might be heard. One is lattice energy, another is what? Hydration energy. There are two factors which influence enthalpy of dissolution. One is lattice energy, another is what? Hydration energy. So copied all of you this. Now write next point. Enthalpy of dissolution. Enthalpy of dissolution depends on how many factors? See? It depends on two factors. What are those two factors, students? One is lattice energy. Might we heard this lattice energy in 11th class? Do you heard this, student? In chemical bonding, you people may heard this. Lattice energy is shown with the symbol U. And there is another energy called hydration energy. So what are the two factors that influence enthalpy of dissolution? Means one is lattice energy, the other one is what? Hydration energy. Now student, what is meant by lattice energy? This, the amount of energy required to break the 1 mole of ionic crystal into oppositely charged ions. That means we have to break the 1 mole of ionic crystal into its ion. Means lattice energy is endothermic. Because why we are spending energy? Getting idea, amount of energy required to break means we are spending energy to break, no? So that process is endothermic. Then what is meant by hydration energy? After breaking the ionic compound into ions, what happens? Water gets solvated. That means water molecules will surround what? Oppositely charged ion, and that energy released is called hydration energy, and this energy will be exothermic. What is meant by exothermic? You are people familiar in thermodynamics. Here heat is evolved, whereas here heat is absorbed. Getting idea, all of you? So two factors will influence enthalpy of solution. One is lattice energy, the other one is what? Hydration energy. Now observe here. Now when I am comparing enthalpy of solution, that means enthalpy of solution, you remember in thermodynamics you people studied. It is the sum of what and what? Lattice energy. Lattice energy shown with U plus what energy, student? Hydration energy. Sum of hydration and lattice energy will give what? Enthalpy of solution. This you people learnt in 11th class in thermodynamics. Now see, if here there are two cases, here I am writing here case 1. See, if case 1, see, I am taking lattice energy is more compared with hydration energy. That means we are spending more energy to break instead of releasing energy. So the process comes to be exo or endo, students. Means delta H is positive. Here the positive value is coming more, this is less negative. So magnitude comes positive. Means the process will be exo or endo, students. Here the process will be endothermic. Understood? So it depends on nature of solute. Same way case 2 you take. If it is, I am taking case 2, tell me, student, what is the another case just opposite? Lattice energy comes less, hydration energy coming more. That means, what does it mean? More heat is released. That means magnitude of this delta U, lattice energy is having less, hydration energy is more negative we are getting. Negative is more means what is this? Exo or endo, students? This comes to be exothermic. Are you getting idea? This is to be exo. Exo means what? Heat is evolved. So for this what happens? Solubility decreases with increase in temperature. What is the another case, student? Case 3 we can get both can be equal. That means enthalpy, lattice energy can be equal to hydration energy. See, lattice energy U is equal to hydration energy. Then in this case neither heat is evolved nor heat is absorbed. That means delta H value will be 0. So copy this. Understood? So enthalpy of solution depends on two factors, lattice energy, hydration energy. If lattice energy comes more than hydration energy, the process is endothermic. For these substances, solubility increases with increase in temperature. Here what happens, solubility increases with increase in temperature, whereas here what happens, solubility will decrease with increase in temperature. Hence, enthalpy of solution, the solubility depends on what? Enthalpy of solution. Clear for all? Following students. So till now what we learned, nature of solute, nature of solvent, how will be the influence of surface area, and how temperature will have influence on solubility of solid in liquid. Are you following on all of it? So conceptual they will ask in exam. Now see, let us draw one graph, solubility versus temperature. Now when you plot a graph, solubility on the y-axis, temperature here. So majority of the solids, what happens? Solubility increases. Like what? Ammonium chloride, ammonium nitrate, and KCl. Why? Their dissolution process is to be endothermic. Here what is delta H for the solution? Delta H for solution is endo. And few substances solubility, what happens? It decreases with increase in temperature, like lithium sulfate. You know lithium, what is lithium? 1A group. And you know ceric sulfate. Ceric, what is ceric? Cerium belongs to F block. Later you study F block element, ceric sulfate, lithium sulfate. This is lithium sulfate. Their solubility, what is happening? Decreasing, because the enthalpy of solution is what, student? Exo. That means here what is the lattice energy? Lattice energy comes less, hydration energy is more. That's the reason more, here heat is absorbing, no? So that means here lattice energy comes to be more compared with hydration energy. Here lattice energy comes to be less and hydration energy comes to be more. So in exam graphical approach also they ask. So what type of graph do we get when we plot solubility versus temperature for substances that undergo endothermic process? Endothermic process, solubility increases. For exothermic, solubility, what happens? Decreases with increase in temperature. Clear all of you? Are you following all of you? So this is what effect of temperature. Now write last one, effect of pressure. Copy them all of you. This right next right heading, effect of pressure. Now see, effect of pressure. Here see, even though we took pressure, actually pressure has no influence on solubility. Why? Later you study solid state chapter. Since solid has incompressible, solids are incompressible, no? We cannot compress them. So hence pressure has no influence on solubility of solid in liquid. What is the reason? In assertion reasoning they ask. So solid, increase in pressure, solubility of solid in liquid is not affected. Assertion. Reason, since solids are incompressible, so pressure has no influence. And in exam they give you assertion reasoning model, no? So A is true, R is true, and R is giving correct explanation. So here make a note. So here write, pressure has no influence. Pressure has no influence on the solubility of solid in wet water, on the solubility of solid in liquid. What is the reason, student? Why pressure has no influence? If they ask the reason, what we say? Since solids are incompressible. As you know, particles of solid are compactly arranged, no? So since solids are incompressible. So with this, what factors that influence solubility of solid in liquid, we completed. Clear for all? So one, it depends on nature of solute, nature of solvent, surface area, temperature, pressure. But pressure has no influence. Done, students. Copied all of it. So now next we go for solubility of gas in liquid. Next our discussion will be on what? Solubility. How solubility of gas in liquid depends. Copy them all of it. Now write next heading, solubility of gas in liquid. Now here also the same factors what we discussed in solubility of solid in liquid. What is the first factor we wrote? Nature of solute and nature of solvent. See, first factor I am writing nature of solute. Here who is solute, student? Gas. And nature of solvent. Solvent generally we take water. Now observe here. Here one point you have to remember. You know, reacting gases. So what is that? I am using a word, reacting gases. See, what are the reacting gases? Reacting gases like carbon dioxide. You know what is the formula? CO2. And these are reacting gas. Ammonia. So these are what? Reacting gases. Reacting gases will have more solubility, because when you place CO2 in water, you get carbonic acid. You know what is the formula of carbonic acid? H2CO3. And you know, in equilibrium chapter, ammonia, when you place it in water, it will form ammonium hydroxide. So are they reacting gases or not, student? So reacting gases will have more solubility in solvent, whereas non-reacting gases. So these gases have more solubility. Why they are having more solubility? Because since they are reacting, more solubility as they are reacting gases. Following? Now see, I am taking non-reacting gases now. Now what are non-reacting gases? See, permanent gases. Non-reacting gases. Then what are non-reacting gases like N2? You know, N2, nitrogen gas, and what else? Oxygen gas. So these are all what are non-reacting gases. So non-reacting gases will have less solubility. So these are non-reacting, their solubility will be how? Less. Hence, we can say that it depends on nature of solute and nature of solvent. That means reacting gases will have more solubility, whereas non-reacting gases like helium, nitrogen, oxygen, their solubility will be less. Why? Because they are less reactive gases. Since they are less reactive. Understood, students? So is it depending on nature of gas solute or not? Copy this. Make a note, reacting gases like carbon dioxide and what else? Ammonia, their solubility will be more. Why their solubility is more? Since they are reacting gases. But non-reacting gases compared with the reacting gases, their solubility comes less. So what are non-reacting gases like N2, nitrogen, oxygen, helium? These are all non-reacting gases, so their solubility will be how, students? Less, no? Why? Because they are less reactive gases. So is it depending on nature of solute and nature of solvent or not? Are you following, students? This is what nature of solute and nature of solvent. Now write B, effect of temperature. How temperature will have influence? Copy them all of you. Nature of solute, nature of solvent. Next write second factor. Now see, second factor, temperature. Now how temperature will have influence? See, dissolution of gas in liquid is exothermic. Means heat is evolved. And you know, Le Chatelet principle, exothermic reaction favor what type of temperature? Low temperature. Whereas dissolution of solid in liquid, it can be either exo or endo. Whereas dissolution of gas in liquid is exclusively what? Exothermic. That's what when we go to vendor, we ask him, give me chilled bottle. Chill means what? Cooling bottle. So in the cooling, as temperature is low, what happens? Solubility of gas will be more. So here what we say, make a note, enthalpy of dissolution is exo or endothermic? Is exothermic. That means heat is evolved. Delta H is negative. That means how we show, see, gas dissolved in water, we get gaseous solution. And this gaseous solution will be exo or endo, student. Enthalpy of solution, you know, no, in thermodynamics we show with negative. That means heat is evolved. So hence what happens to solubility of gas with increase in temperature, they ask in exam. So with increase in temperature, solubility of the gas decreases. Right here, as enthalpy of solution is, dissolution is exo, as temperature increases, what happens to solubility of gas in liquid? Solubility of gas in liquid decreases. Since delta H of solution is exo. Understood. Whereas dissolution of solid in liquid can be both exo as well as endo, whereas here it is only exothermic reaction, I means heat is evolved. So with increase in temperature, solubility of gas in liquid decreases. That's what you know, aquatic animals like fishes, tadpole, they can survive in where? Winter season, cold condition. So as temperature increases, what happens? Solubility of the gas decreases. Understood, student, all of you? This is what important in exam. They ask you what happens to solubility of gas with increase in temperature. They give option increases, decreases. It may neither increase nor decrease. It is not affected. So which option you have to choose? It's, and with increase in temperature, solubility of gas in liquid decreases. Here. Now we go for the third factor, very important. This in exam they're asking question. Henry law. Right? Effect of pressure. What is the third factor, student? Effect of pressure. Now see the last factor within 3 minutes, 5 minutes. Effect of pressure. Now this is very important, student. In exams they are asking JEE mains as well as in NEET point of view. How pressure will have influence on solubility of gas in liquid? Might be you saw in daily life cool drink bottle. Cool drink bottle, if you see soda water like Coca-Cola, Thumbs Up, when you open the lid, you will observe the gas is coming out. Do you saw that in real life? So what is this effect of pressure? There is a scientist called Henry. What is the name of the scientist? Henry. Henry has given one statement. What is that statement? See, the mass of the gas dissolved in liquid is directly proportional to partial pressure. So mathematically how we write? M is proportional to P, keeping what constant? Temperature constant. So what is the statement given by Henry? The mass of the gas dissolved in a given solvent is directly proportional to partial pressure of the gas. That's what they do. The soda water is sealed under high pressure. When pressure is high, what happens? Solubility of gas will be more. Are you getting my point? So this was the relation given by whom? Henry. So make a note, what is the statement? Mass of gas dissolved in a solvent is directly proportional to partial pressure of the gas. So where M is mass, P is what? A partial pressure. Here what is M here, right? M is mass of gas. What is P, student? P is partial pressure. keeping what temperature constant. Understood? Simple. This is important in NEET as well as JEE mains. Henry's law. Henry is a scientist. He has given a relation how much amount of solute gas dissolved in unit mass of solvent is directly proportional to what he said, partial pressure of the gas. So mathematically we write M proportional to P. Write the term where M is mass, P is pressure, partial pressure. This is important, put star mark. Clear all of you? Simple. Now remove proportionality, student. When you remove proportionality, I write here what we write, M is equal to K into P. What is K here? Proportionality constant. Right here K is proportionality constant. Proportionality constant. K is a constant. So keep this relation in box. Where M is mass, K is proportionality constant, P is what? Pressure. Up to this understood all of you? Simple. So what Henry said, mass of the gas dissolved in unit mass of solvent is directly proportional to partial pressure of the gas, is said. I mean, mathematically we write M is equal to K into P, where M is mass, K is proportionality constant, P is what? A partial pressure. Clear? Understood? Now observe here. Now a scientist called Dalton. Do you heard him? Dalton, in first year you studied states of matter. So Dalton, what he assumed, the solubility is taken in terms of mole fraction. According to Dalton, solubility is a measure of what he took. Solubility is taken as a measure of mole fraction. What is mole fraction, student? You are familiar last class. Mole fraction is shown by the symbol of what? Chi. What is the symbol of mole fraction? The mole solubility. How much amount of gas is dissolved? That is solubility. No, that is it is taken in the measure of what he said, mole fraction. So according to Dalton, later Dalton is a science student of Henry. So what Dalton said, the amount of gas dissolved in unit mass of solvent is taken as a measure of what he said, mole fraction. Mole fraction is shown with the symbol what? Chi. Understood, students? So now I write it in next page. Up to this copied, everyone. So solubility is taken as a measure of mole fraction. Now what we write, students, say according to Dalton, now the solubility which we are taking in terms of mole fraction is directly proportional to partial pressure. So here X is what? Mole fraction. And what is P? P is partial pressure. Getting idea what I am saying? So where X is taken as a measure of solubility, this mole fraction is taken in terms of solubility. The solubility of the gas which is taken in terms of mole fraction is directly proportional to what? Partial pressure of the gas. Now remove the proportionality, we get chi is equal to, already we introduced K, no? Now I am assuming K prime because in order to differentiate between the previous one and this one into P. So what is K prime? K prime is a constant. Now obtain from this P. P is equal to what should I write? X by K prime. Understood? P partial pressure is equal to, I brought this P is equal to X upon what? K prime. And this reciprocal of 1 by K prime, we are calling it as Henry constant. What is this reciprocal of 1 by K prime is taken as Henry constant. Now onward Henry constant is shown with the symbol of what? KH. Now what is the relation? We can write in place of that, the partial pressure of the gas is equal to KH into chi. This is the second statement we can give from Henry's second law. So this is the second statement. That means partial pressure of the gas is directly proportional to what? Mole fraction. So here right statement. What is the another statement from Henry law? We say partial pressure of the gas. Partial pressure of gas is directly proportional to mole fraction. Directly proportional to mole fraction of the gas. And what is this kh called? This kh is called a Henry constant. To honor Henry, we are calling this as what? A Henry constant. kh is called Henry constant, where p is partial Bayer. What is p partial Bayer? What is chi? Chi is mole fraction. This is the important relation in JEE mains as well as in NEET. We get numericals on partial Bayer. So in the problem they give you partial Bayer, mole fraction, and they may ask you to find kh. What is kh called? Henry constant. Understood, students, all of you? Now write units of kh. We continue tomorrow. Tomorrow we continue with the units as time is over. So up to this, copy this relation, partial Bayer is equal to kh into x. And tomorrow we do numerical on this solubility of gas in liquid. And tomorrow while coming, once read the content till now what I taught, understand the concept, and tomorrow you join all of you. Okay, ma, all the best. I'm ending the session. Copied everyone, this copy it fast. This is the relation given from Henry's law. Are you following me, everyone? So the thing is, on the day what we teach, you recap the content in the class what I taught. That you have to work on it, understanding, and you have to work on it. Okay, right. All the best. I'm ending the session. Copied everyone this one.